In 2024, construction workers at the Denver Museum of Nature and Science were drilling deep beneath the museum's parking lot. The project was meant to install a geothermal heating and cooling system, a step toward a more sustainable future. Instead, the drills struck stone unlike any other. Within moments, fragments of bone were revealed, embedded in ancient sedimentary rock. At first, the crew assumed it was just another piece of rubble. But when paleontologists examined the object, excitement spread quickly. What they held was not ordinary stone. It was a vertebra, the fossilized backbone of a dinosaur that had walked the Earth more than 6-7 million years ago. The coincidence was staggering. Beneath cars, asphalt, and modern infrastructure lay the remains of a creature from the twilight of the Cretaceous. For Denver citizens, this was more than a scientific discovery. It was a reminder that the land itself held layers of forgotten worlds, waiting quietly beneath everyday life. A parking lot meant for convenience had become the unlikely doorway into prehistory, a connection between city life and the Age of Dinosaurs. The fossilized vertebra belonged to a small herbivorous dinosaur, most likely a hadrosaur, the so-called duck-billed dinosaur that once roamed Colorado's floodplains. Hadrosaurs were some of the most successful plant-eating dinosaurs of the late Cretaceous. They traveled in herds, browsed on ferns and conifers, and raised their young in nesting grounds near rivers. Their distinctive flat snouts allowed them to grind vegetation with complex dental batteries, an evolutionary innovation that made them highly adaptable. To find even a single bone of a hadrosaur in Denver's city center was extraordinary. Fossils in Colorado are usually found in remote exposures of sandstone and shale, not beneath asphalt. Paleontologists knew that the Denver Basin contained layers from the Mesozoic. Yet the chance of encountering fossils in an urban dig was incredibly slim. This bone, locked in stone since the last days before the asteroid impact, surfaced because of a modern effort to harness clean energy. It was as though the past had chosen to reintroduce itself precisely when the city looked toward the future. The vertebra became both a relic of ancient life and a symbol of Denver's unique connection between innovation and history. Colorado has a legendary history in American paleontology. In 1877, just west of Denver, the town of Morrison became the birthplace of discoveries that defined the Jurassic period. The Morrison Formation produced Stegosaurus, Allosaurus, and long-necked sauropods like Diplodocus. These finds ignited the infamous Bone Wars between Othniel Charles Marsh and Edward Drinker Cope. Two rival paleontologists who raced to name new species and outdo each other's discoveries. The fossils of Morrison shaped our understanding of dinosaurs and fueled public fascination for generations. Later, across the state, additional quarries revealed immense sauropods such as Apatosaurus. Colorado earned a reputation as one of the richest dinosaur regions in North America. Yet never before had Denver's own museum grounds yielded fossils. The discovery beneath the parking lot adds a new chapter to this legacy. It reminds residents that the history of paleontology in Colorado is not confined to distant quarries or desert badlands. It can emerge even in the heart of the state's largest city. For historians of science, the Denver fossil is both an echo of the 19th century fossil rush and a sign that unexpected surprises remain possible. The Denver fossil is dated to roughly 7.5 million years ago, placing it in the late Maastrichtian stage of the Cretaceous. This was the final era before the catastrophic asteroid impact that ended the reign of dinosaurs. At this time, Colorado was a landscape of rivers, swamps, and forests along the edge of the western interior seaway. Vast inland seas stretched from the Gulf of Mexico to the Arctic, dividing North America into The Denver Basin lay on the western shoreline, a low-lying floodplain where dinosaurs, turtles, crocodiles, and early mammals thrived. Sediment from ancient rivers buried their remains, preserving them for millions of years. The hadrosaurs that grazed in these wetlands lived side by side with horned dinosaurs such as triceratops and predators like Tyrannosaurus rex. Each fossil from this age is vital for reconstructing ecosystems before the extinction. Did dinosaur populations decline before the impact, or were they thriving until the sudden catastrophe? A vertebra beneath a museum parking lot becomes part of this larger mystery. It is not simply a bone, but a clue to one of the most dramatic turning points in Earth's history. For paleontologists, a vertebra provides much more than size and shape. Microscopic analysis reveals bone tissue structure, growth rings, and even signs of disease or injury. By studying the fossil under powerful microscopes, scientists can estimate the dinosaur's age at death, how quickly it grew, and whether it suffered stress in its environment. Stable isotope analysis can suggest the type of vegetation it consumed or the climate in which it lived. Though small in size, the bone may carry information that connects Denver directly to global patterns of Cretaceous life. The fossil preparation team carefully removed surrounding rock, hardened the fragile structure with resins, and documented every stage of cleaning. Each detail matters, because context is as valuable as the fossil itself. How deep was it buried? What sediment surrounded it? Was it isolated or part of a larger skeleton? These questions drive further investigation. If additional bones lie beneath the surface, Denver could become home to a new, more complete specimen. Even if this vertebra remains solitary, it still enriches scientific knowledge. For paleontology, every discovery, no matter how small, contributes to the mosaic of life's history. The cultural impact of the find cannot be underestimated. For Denver residents, the story captured headlines: a dinosaur bone found under a parking lot right in the middle of the city. It was compared by scientists to hitting a hole-in-one from the moon, a phrase that perfectly expressed its improbability. Local news outlets shared the tale widely, and visitors flocked to the museum to see the discovery firsthand. For families, the story made dinosaurs feel immediate and real. Instead of distant creatures from deserts or foreign lands, they were neighbors who once walked the very ground they now drive upon. For audiences in their 40s and older, the story blended nostalgia with reality. Many had grown up during the dinosaur boom of the 1990s, when Jurassic Park reignited global fascination. Now, hearing of a fossil beneath a familiar parking lot connected those childhood memories with a tangible object. It bridged imagination and science in a way no blockbuster could. For the museum, the discovery became a powerful educational tool. It reinforced the idea that science is not far away or confined to textbooks. It surrounds us daily, hidden in the ground beneath ordinary places. The geology of the Denver Basin offers insight into why fossils appear there. The region formed as the Rocky Mountains uplifted during the Laramide orogeny in the late Cretaceous. Rivers carried sediments eastward, burying plant and animal remains under thick layers. Over time, minerals replaced organic material, turning bone into stone. Fossils preserved in these layers record a changing world as mountains rose and seas receded. Denver itself sits at the junction of deep geologic history and modern human settlement. Beneath office towers and highways are layers that once held ancient ecosystems. The parking lot discovery illustrates how urbanization does not erase geology. The land remembers. Every construction site has the potential to disturb or reveal fossils, though most remain unnoticed. For scientists, this realization encourages collaboration with builders and city planners. With careful observation, more discoveries could surface in unexpected places. The Denver fossil may inspire future partnerships where paleontologists are consulted during major projects. In this way, development and science can coexist. Instead of destroying hidden history, cities might become participants in preserving it. The Denver vertebra becomes both a specimen and a case study for urban paleontology. When compared to other fossil sites, the Denver find is modest. It lacks the completeness of Sue the Tyrannosaurus Rex in Chicago or Big Al, the Allosaurus from Wyoming. Yet, its importance lies not in size, but in symbolism. It demonstrates that science thrives on serendipity. A routine construction project became a scientific event. It shows that discoveries need not occur only in remote deserts or vast quarries. They can happen in backyards, schoolyards, or beneath a museum parking lot. For scientists, this fosters humility despite advanced technology. Chance still plays a role in uncovering history. For the public, it fosters wonder, the idea that ancient life surrounds us, invisible until revealed. This perspective encourages curiosity in everyday life. Children may look at stones differently, wondering if they too hold secrets. Adults may reflect on the deep time beneath their feet. The Denver fossil becomes less about paleontology and more about perspective. It teaches that every place, no matter how ordinary, has a story stretching back millions of years. The fossil is a reminder of continuity, connecting ancient ecosystems to modern society through a single piece of bone. The Denver Museum of Nature and Science plans to display the fossil, not because it is the most spectacular specimen, but because of the story behind it. Visitors will see the fragment and read how it was discovered during construction. They will learn that it is 7 million years old, from the last chapter of the Cretaceous, and possibly belonged to a hadrosaur. They will understand that it was found not in a quarry far away, but directly beneath their city. This story transforms perception. Instead of fossils being distant, they become immediate. Instead of dinosaurs being abstract, they become neighbors of the past. For educators, the fossil provides an opportunity to discuss geology, extinction, and the fragility of ecosystems. For scientists, it provides data to add to global research. For citizens, it provides pride that Denver, already a cultural hub, is also a site of paleontological significance. As the museum integrates this fossil into its exhibits, it ensures that future generations will see not only the grandeur of dinosaurs, but also the humble ways in which they are rediscovered. A parking lot vertebra becomes an ambassador of science to the community. Ultimately, the Denver parking lot dinosaur fossil symbolizes continuity. It links the prehistoric past to the modern present. It reminds us that every piece of land, no matter how developed, rests atop layers of history. For those who study paleontology, it is a scientific clue to ecosystems before extinction. For those who live in Denver, it is a story of pride and wonder. For those who grew up fascinated by dinosaurs, it is proof that the creatures were real, not just cinematic legends. The vertebra teaches that discovery is not finished. There are still bones in the ground, still stories waiting to be told. It is possible that more fossils remain beneath the museum or beneath other parts of the city, awaiting their moment, whether or not they are ever uncovered. The lesson remains. Science is alive, fueled by chance, context, and curiosity. A parking lot, intended for cars and asphalt, unexpectedly revealed life from an age when giant reptiles ruled the earth. That juxtaposition is what makes the Denver discovery unforgettable. It is not only a fossil, it is a reminder of deep time, resilience, and the endless potential for discovery in the world around us.